Hello everyone, welcome back to another video. Today I'm doing this problem: design, add and search words data structure. I did this problem on 25 Jan. Interesting thing, well, not really interesting thing. Um, I missed the most important part of this problem, which was word may contain dot, where dot can be matched to any character. And really, without this part, there is nothing new to this problem. And by the way, I was watching my own video solving this problem, and I realized that I kept pronouncing it tree. I found out that it's not a tree, you call it try. Yeah, so I'm gonna fix my mistakes in this video. Yes, so let's, and this is where I left off last time, and I'm just gonna continue from here because this all the rest of this is the tricky part in this problem, and rest of this is really similar to try problem, the other try problem. Okay, and so yeah, this is I need to implement the search function again. And well, the solution I looked at last time, like most of the solution I looked at, they are using recursion to find the word. So I'm gonna try doing that, and let's see let's see if I can get it. So yeah, return true if there is any string in the data structure that matches word, or false otherwise. Uh, for example, so in my dictionary I have bad, dad, and mad. We try to look for bad, it's not here in the dictionary, so we return false. Here, we try to look for dot ad. Now this dot can match to any character in my dictionary, so let's try to match it to the first character we found, B, right? So BAD, bad. So we have bad, and then there is B and dot dot. So yeah, let's try to implement this. I'm gonna say it's a recursion function, right? So let's make a new function, private void search word. Okay, and I'm gonna pass in it will accept a character, current character probably. So I can say if current is not equal to dot, if current is not equal to a dot, then simply return or if it's not equal to a dot, then do something. But or if it is equal to a dot, then search word, we can just skip this, with I also need an index. Okay, I need to keep track of the index, right? So yeah, I'm recording. So yeah, an index. instead of this char, I'm gonna accept this original word. Okay, and I am first of all checking that my index is smaller than my word size. If it's greater than or equal to, then I don't know, return. Let's have my current. Current is a character at index. Okay. Uh, hmm. Okay. And let's also pass in my try root. Well, if this is a normal thing, if this is a normal character, then I can just check like this, index current dot character get. Yeah, it's a hash. No, I don't need hash map. I don't need hash map. I don't need a hash map. I just need a character array. No, I need a try array. Or 26 character, 20 of length 26. New try. 26. And here new If at this root.org, mm, I'm confused about this part. This should I? I think I should handle this. Search word. Index. So I don't have to worry about the size of the list and the each character in this one. So index. This function is only concerned about finding the character, not worrying about the whether we are in the legal range or not. So now let's pass in current. And let's remove this. Okay. And well, I'm gonna need let's see. I'm converting my this to word array. So I need to know if if my is dot else doing this is fine. Okay, and I think I'm just if current dot character, I'm just repeating myself here, is equal to null, then return false, else move my current is equal to current character index. Yes, and at the end look for the completion of the word. Current dot end of the word. Okay, I just repeated myself here. But now I can see it a bit more clearly now. So for this, whenever I have dot, I can essentially match it to any character. In that case, I need to get my I should get my new root, and if this tree should return my updated root. I'm worried about for example, B is here, then there is dot. I should check it alphabetic. I should start from A, check every character in my list. I know bad is here in my list, which starts from after B there is A. This is easy. But what if essentially how many paths we can explore. How many paths for, I think every time there is a dot, we have to search every do we have to search 26 paths for each character and then checking uh, that seems like a very um, if my root dot character uh, at this index uh, at this index is not null, then what we can do is maybe do this something like this. Uh, this is just like saying, okay, any first character, valid character we find where it can match to, just return that. So make my root of character equal to that. Uh, what kind of index I'm passing here? What is the initial value? What is the initial value? What is the base case? Wait, I don't need this. Hmm. Boom, boom, boom. If I find the dot, you know what, let's paste this here. I don't care about recursion. You shouldn't do it if you don't understand it. Especially, you should not do it, especially when you have seen it, someone using it, and you think you can replicate it. If there is a dot, then if is I minus if copy this code. Not man. Well, check that index. Check that index. Current is equal to current. If that code is not null, I don't know, make my character dot character index equal to that index and break from this loop. We found a character and yep, let's try. I know this is not right. "26 characters. Index what? 50? Okay, 150 here. A A A A. No. I got false for the case without a dot. So yeah, so it's not even working in a normal sense. CH A this character. Adword. Search bad. Bad is not in my array. Then search for bad. BAD. Expected was true, but I got false. True was accepted. I produced false. Clean this up a bit. Still false. Bad is there in the array, idiot. Bad is present in the array. System.out.print just a sec. What am I doing wrong? Is null really the default value of each character? I know what I'm doing wrong here. I'm not properly exploring the path here. So what I need to maybe do is int k is 0 while k is smaller than my word length. K plus plus character is equal to k dot character at, I mean word dot character at k, it's ch, okay, and hang on, let's start this k from a arbitrary index. Start this, let's move this entire block into a function I created somewhere here, but now it's gone for some reason. Create it again, void search k started from some index that we are expecting, int idk, okay, and let's say we are also expecting word k plus plus character at k, with search word index plus 1, or plus I, let's say I, word, no, not I, plus 1 and word, and I also need to move my root here. I'm very current dot, I mean my tree, so yeah, of course I'm using the same name, so it cannot be I, it cannot be I, it cannot be idx. Now it, oh god, let's index, it will start add some index and index plus 1 and okay, and try current. Return current is end of the word, else return. Hopefully with this boolean Then search word starting from 0 word and current. Not sure if I should make this thing return this current, and then I can probably move this condition here. But yeah, let's try this for now. And who got it right on the first try? Search word, missing parentheses. This is why I like Kotlin. No. It's not even working for the normal days. Okay, I think time to give up. Time to give up. Search. Oh yeah, I'm not really returning true from here, right? I should return true. What does this mean? Is it? Okay. Okay. We are not well, if this is true, then only return true. I mean, if this is true, then return true. If it's not true, then keep processing this. And okay, I got it now. This is like saying that if we haven't found any character between from 0 till z, from a till z in my current, then there is no point. We do not have any character at this point in my try, so just return false. I think I'm doing something wrong here. The only difference between this one solution and this is that this solution is checking for this is only checking for the characters that are already in the try. Here I'm checking for all the alphabets starting from A to Z. That's fine, that's good. Else, so what you should do is okay, if it's not here, yeah, this is fine, the code is fine. Maybe I might be doing something wrong somewhere. Hint, at least can I get a hint? Okay, um, I need a lot of time to debug that. So, thank you for watching this video. This was the second attempt. Still can't get it right, but that's okay. That's a part of practice. We are here to practice. Yeah, thank you so much for watching this video.